Finally, how to contain an evil four-dimensional creature. Now suppose that there's a fourth dimension. It helps a lot of people to use time as the fourth dimension. Physicists do that, so we will here, although it's not necessary. We could just have it be another dimension. Let us further suppose that there's an evil four-dimensional creature that can travel freely in the four directions. This means flying like a bird in the usual three directions and traveling forward and backward in time as well. Now, we're going to suppose that this creature cannot teleport, disappearing from one moment of time and instantly appearing at another. We have no way to stop teleporting birds or teleporting werewolves, as such creatures are uncontainable. Why could they just, leave your jail and appear somewhere else? Thus, we will suppose that this creature can make the clock spin rapidly forward or backward, but can only reach past and future times by moving through all the intermediate times in between. Now, a student in the past pointed out that Carmen Sandiego, star of the 1989 video game Where in Time is Carmen Sandiego, had exactly these properties. She was a bad guy, she traveled through time, she did things like messing up moments in history and such like that. She will be our villain. Ta-da! There you are, Carmen Sandiego. If we ever could catch her, which would require knowing a lot of geography and history facts, we would need to find some sort of jail to contain her. If we tried putting her in a normal prison, she could just travel rapidly through the future, making the clock spin maniacally into the far, far future until the jail cell collapsed into dust. Or, even easier, she could travel backward in time to a point before the construction of the jail cell was complete, and then jump through the incomplete wall and escape. However, first consider a prison cell in the shape of an empty box with small holes in the top and in the bottom, and it helps if your floor is kind of sloping down to that hole. First, we block up the bottom hole and pour in through the top sand until the entire jail cell is a solid three-dimensional box, absolutely solid, packed filled with sand. Next, we open up the hole and hopefully get all of the sand to drain out. We have an empty box again. And into that box, somehow, we put Carmen Sandiego. I'm not sure how we figured out how to put our bird in the box or whatever. Maybe we could construct this around her. Anyway, kind of tricky. And because we're not heartless, we put in pie and coffee. Right. Next, we wait a few days, and then we fill the box back up with sand again. Ta-da! Now, at some point, the sand is going to dump down on her. She'll be suffocating in the sand. She'll be being crushed under its weight. And she'll say, "You guys are inhuman. Why are you doing this to me?" And we'll say, "Hey, we know you can travel through time. And if you keep going, if you stay in this moment, you are going to be crushed with sand and die. So, travel backward in time to an earlier point when you had that pie and coffee and we were being nice to you." She says, "Curses! She can't travel through the future, because if she travels too far, she will be crushed in sand." So she thinks, "Ha-ha, I can't travel into the future. This blocks her off from traveling in the future. She can fly like a bird." I don't know if she could do that in real life, but I'm letting her fly like a bird. She's inside a three-dimensional hollow box. She can't do that. She tries traveling backward in time, and as she travels backward in time, she realizes that she will meet the same crushed by sand fate that she was facing in the future. In general, here's how I depict a four-dimensional cube. You have a time dimension, you have a fourth dimension. It doesn't have to be the time dimension, it could be any dimension, but we could suppose it's time. At one point in time and one point in the fourth dimension, we have a solid three-dimensional box. At another point later in time, we have a solid three-dimensional box. And at every point in between, and there's infinitely many points in between, at all the points in time in between, we have a hollow box. This is a four-dimensional cube. And if you think about it, if you think about all the boxes in between here, you will have some sort of picture of what a four-dimensional space is like. If this might be 10 feet tall and 10 feet wide and 10 feet deep and 10 days wide in the fourth dimension. Or it could just be 1 unit by 1 unit by 1 unit by 1 unit in the fourth dimension. And we can plot some of these points. We needed this to have, what did it be, 16 vertices? 1, 2, 3, we have 1, 2, 3, 4, 5, 6, 7, 8. The 8 vertices on this end, and 1, 2, 3, 4, 5, 6, 7, 8. The 8 vertices on this end for a grand total of 16 vertices. This vertex, for instance, is 0 in the x direction, 1 in the y direction, 1 in the z direction, and 0 in the t direction. Whereas this vertex over here is 1 in the x direction, none in the y direction, 1 in the z direction, and 1 in the t direction. There are 16 vertices. Now, you might be like that one-dimensional creature who we also need this to contain, 8. This has to be made of 8 solid boxes. Well, you say, okay, here's one solid 3-dimensional box. Here's 2 solid 3-dimensional boxes. Where's the other 6? Well, look at this side of the box. It is like a solid square, a solid piece of paper. And we have how many of them? We have infinitely many of them stacking through the distance from 0 to 1, and it attaches to this side of this cube. We have these squares all the way through time, all the way through one dimension. And if you have a stack of solid square on top of solid square on top of solid square, all the way down through this t dimension from t equals 0 to t equals 1, and you stack these all up, you pack them together, this is not very well drawn, you will get a solid 3-dimensional box. And in fact, yes, these sides all the way through the t dimension forms the 3rd box, and these sides form the 4th box, and the tops of all the boxes form the 5th, and the bottoms of all the boxes form the 6th, and that side forms the 7th, and that side forms the 8th. And there are your 8 solid 3-dimensional cubes which make up this 4-dimensional box, this hollow 4-dimensional box. And to make a solid 4-dimensional box, even easier. Just make all the boxes in between solid.